How's it going, you guys? In this video, we're going to be looking at piecewise functions. So what a piecewise function is it's essentially what you can see here. But what's really happening is it's modeling real life more than anything in the world. Right? If I use my glasses. If I throw up my hat and I hit it down, right? Throwing it up is creating one function. Like throwing it up, creating a function. If I don't touch it, it stays that function. But as soon as I change it, by hitting it straight down, I don't know if you can even see that going that fast, so I'll try it again. Throw it up, hit it out of the air, right? It changes the way that the function is working. So that's essentially what a piecewise function does for us. So like the act of throwing the hat up, the hat was going up and then it was going to reach this like equilibrium up here. And then when I threw it down, it made it go down a lot faster than it normally would have. Otherwise, it would have just been like an up and a down, like parabola type thing. So I kind of forced it down a little bit faster than it should have been going anyways. So that's essentially what a piecewise function is. So let's see how we can actually graph these things. So the first thing I notice is I have kind of two different equations in this thing. So it's saying it's this equation only when the x values are less than 0, and it's this equation only when the x values are greater than or equal to 0. So we're kind of creating two different equations. What I like to do is I like to take this 1/2 x minus 3 and graph it by itself. It would have a y-intercept of -3, right? And then it would be up 1 over 2, so up 1 over 2, and I would have a line going something like that. So now it's saying the x values only exist when they are less than 0. So what I need to do is any x values for this graph that are greater than 0, I am not going to include those on my actual graph. So I had the y-intercept of -3, and I'm not equal to 0, right? It's just less than 0, so I'm not equal to it. And then the slope would have been up 1 over 2, but I can't go that way because those are where the x values are greater than 0 over here. So instead I'm going to go down 1 over 2, such that this line is only acting right there. All right, same sort of idea, but the other direction. This -2x plus 4, God, my hair is terrible. So I have a y-intercept of 4, so I'd be up at 1, 2, 3, 4. And then I would have a slope of down 2 over 1, so I would have a line going something like that. So now, this one says only when x is greater than or equal to 0. So any x values that are less than 0, which are all over there, I need to take off of my graph. So when I put that on my actual graph, I had the y-intercept of 1, 2, 3, 4, and it says greater than or equal to, so I'll go ahead and close it in. Anytime we're equal to, we're going to graph it in, just like with those dashed and solid lines. Anytime we were equal to, we drew something solid. So I'm drawing a solid point, and then I'm going to do my slope of down 2 over 1, and continue that line where my x's are greater than or equal to 0. That's all that a piecewise function is. All right, let's look at a few more. So here, we have some functions that you guys may have not seen yet. This x squared. I'll be explaining this. No, you should be seeing it in the other one, I believe. I sneeze. Don't sneeze. No? Okay. All right, x squared is a parabola. So it looks like that. This -3 is actually going to move it down 3, so I'll take that graph and I will move it down 1, 2, 3, such that I have a parabola something like that. So now this says x is less than or equal to -1. So at -3, I'll go up 1 over 1, and then it's all over there for that part of the parabola. Because my x value is -1 right here, so I need to get rid of anything where it is not less than or equal to -1. So now this other part is a cubic function. A cubic looks kind of like that, right? And then that +1, all it's going to do is move our function up 1. So I have a cubic that's moved up 1, and I have to stop at -1, so this point right here, and it says it's greater than, so I'm going to put an open circle, and then continue my cubic in that direction. I'll have a point there, and then have another point way up here. All right, so that's essentially that piecewise function. All right, moving on. You know. Get off the screen here. Nobody likes you. All right, so we have, going back to lines again, use a little bit easier. So again, two functions, two restrictions. So I have negative 1/3 x minus 2. If it helps you, draw this off to the side. So I have down 1 over 3. So I have a line going something like that. All right, and then if it says x is less than negative 1, I need to figure out where it is at negative 1 and get rid of anything else. So what I like to do to figure out the y value for this point at negative 1 is I actually plug in negative 1. So if I do negative 1/3 times negative 1, that's 1/3, just positive, minus 2 is like negative 1 2/3. So at negative 1, I'd be at negative 1 2/3. You could also use the slope. So we're going from negative 2 down 1 over 3. I would go up 1 over 3. So I would be going to that point right there. So I would draw the best line I could going out that direction. All right, and then 2/3 x plus 1. Now notice it says x is greater than 1, so they're not actually meeting. There's going to be some space here in the middle. So when x is greater than 1, so if I plug in 1, just to kind of help myself do it without drawing the picture. So if I put in 1, that's 2/3 times 1, which is 2/3, plus 1 is 1 2/3. So when x is 1, y is 1 2/3. This is also an open circle because it says it's just greater than. So now from there I can do the slope of up 2 over 3. I could also go from the y-intercept, pretend I'm going from here, go up 1 2 over 1 2 3 to get my next point, and then draw your line going out from there. That's really all a piecewise function is. It's just chopping it up into different segments. All right, looking at the next part, the last type of thing that you're going to see with piecewise functions is actually evaluating them, which is really not hard. So remember for me, so it says evaluate the following to each function, or follow words. Evaluate the following using the function f of x equals blah, 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 blah. So notice we have a bunch of restrictions on this right-hand side, and we have a bunch of functions on this left-hand side. So depending on where our x value falls will depend on which function we use. So here, notice instead of an x, I have a negative 3, right? So you got to ask yourself, is negative 3 equal to 1? No, it's not. Is negative 3 greater than 1? It's not. Is negative 3 less than 1? Yeah! So since negative 3 is less than 1, it fits in this restriction right there. So I'm going to use this function to calculate my value. So I will do 2 times negative 3 minus 3, which would come out to be negative 9. That's the only value we have at that point. Moving on. If we have f of 2, think about where f of 2 fits, where the x value 2 fits into my equations. I know that 2 is greater than 1. Since 2 is greater than 1, I only use this equation. So I'm going to say 2 squared plus 2, which would be 6. There's my value. All right. With this one, I have an x value of 1. Well, 1 is equal to 1, so I need to use this one. So I have 4 times 1, which would just be 4. For negative 6 is less than 1, so it only works for this one. It's not equal to 1, it's not greater than 1, it's only less than 1. So I need to use this function, so 2 times negative 6 minus 3 equals negative 12 minus 3, so negative 15. All right, hopefully this helps you guys with piecewise functions. I know they can be a little bit challenging, so also feel free to email me. I'm here for you guys anytime. If you want more explanations and you're not able to get me very quickly through email, remember I'm only responding every 2 to 4 hours. So if you want to look up more videos on this, it's probably one of the more difficult videos that we've done so far. So just look up, I ran out of space. Look up online piecewise functions. If you look this up, you will find a bunch of videos. Almost all of them are good, so just find the ones that excite you the most. All right, always let me know. I'm here for you guys.